Hello and welcome to another Tycho video. Today I'm going to be talking a little bit about the new display functionality that has made its way into the new 11th version of the Tycho software. This would include the display stretch function, channel selector, and color calibration. So to go ahead and get started, first I'm going to be talking about the display stretch function. So here we have a comet, and as you can see, it is comprised of both very faint features as well as a very bright core. So with a linear stretch, you have this sort of behavior where if you try to essentially make it where the core is not overexposed, then you lose out on that very faint detail, the very faint features of it. So this is what a linear stretch would look like, but ideally we'd like to be able to show both of those components at the same time. So if we wanted to, we could go to Settings, Display Stretch, and enable this function here, this hyperbolic stretch. And this gives us a few options here, but already right off the bat you can see that this is an improvement. But if we wanted to, we could make some adjustments to it. So we've got three different sliders to adjust. And so as you can see here, as I move them around, what kind of impact that has. Now this becomes more evident with other images, and I will be showing those here shortly. But again, this just for a very short and quick demonstration, you can see what we're looking at here. So it's a nice feature to have. And again, this is one of the new features available in the 11th version of the Tycho software. So with that, let's go ahead and move on to color calibration and channel selector. Okay, so I will be working through two different examples. In this first example, I have data that was captured from a one-shot color camera. In particular, this is data captured from the C-STAR telescope, which is a quote-unquote smart telescope, and it is a 50mm refractor. And I'll also be doing a separate video on it just to show off what kind of capabilities it has and what kind of measurements you can actually generate using that instrument. And in the second example, I will be working with data that was captured from a monochrome camera with filters. So to go ahead and get started, again, this is this first example, data captured from a one-shot color camera. So I've got 132 images here, and just to give you an idea of what we're working with, I can go to Action, View Images, and this is the Orion Nebula M42. And if I zoom in here, you can see sort of that pixelation that is evident when working with a one-shot color camera. So the first step is to go to Action, Debayer Images. If the images have not already been calibrated, you would do that first, but in this example they have been. So go to Debayer Images, and you've got two different output modes here, either combined luminance or split RGB. I typically choose combined luminance if I'm trying to create measurements of an object from this kind of data, because it essentially preserves and maximizes signal noise ratio. But if I want to preserve color, then I choose split RGB. And then you also have the different interpolation modes here, which you can read about in this window. But for now, I'm going to go ahead and click OK. And again, this is doing split RGB, so it essentially triples the amount of files. So we have one file for each color channel, red, green, and blue. And the next step then is to do plate solving. So I go to Action, Plate Solve Images, and I'm going to go ahead and allow it to do a batch solve. In other words, I have unchecked this box here. If you wanted to have it go quicker or more quickly, then you would check this box, and that's another way of doing it. If you do solve only the reference image, it's faster, but you're limited to doing just a star match type of alignment. But since I want to demonstrate the drizzle module, and the drizzle module makes use of having a plate solution attached to each image, that's why I'm having it do a batch solution here. Again, it is slower to do it this way, but it also offers a few more options. So I'll go ahead and give it a moment here to finish, again, this batch solution. And drizzle, if you're not aware of it, what it allows you to do essentially is to basically perform alignment and stacking in one pass. So here it is, Action, Drizzle Images. Now keep in mind, this module is not to be used if you are working with moving objects or essentially a time series type of measurement, because again, all it's going to do is stack all of these images, and once you've done that, then you cannot work with time series data. So it's really, this module is only to be used if you're trying to create a quote-unquote pretty picture. So just keep that in mind. So I go ahead and click OK here, and again, it can take a moment because it has perform alignment and stacking. Well, it's actually already finished. So here we have 3 images now, again, 1 for each color channel. So I can go to Action, View Images, and this is the result of that stacking operation. So here we're looking at the blue channel, here's the green channel, and the red channel. So the next question is, okay, how do we get a color display out of this? So a couple ways to do it. I can go to Selection by Filter, and having done that, we have now this new window, and if I wanted to, I could choose each color filter manually, and I could map it to a color channel, again, manually. So if I were working with a set of images that did not correspond to common filter names, then I might do that. Otherwise, if they do have a common name, R, G, or B, then I can actually choose this option here. But just to demonstrate, here I have the blue filter, so I can say apply to blue, and I can choose red and say apply to red, and then finally choose all of the green images and apply to green. So what that has done is it has populated this table here. So I've got red, green, and blue, and then I can also double click now on the composite channel. So the composite channel is basically all of them combined. And if I had a luminance channel, I could also populate that as well. But for now, this again is one way to do it. The other way is because these do have a common name, the R, G, or B designations, I could have chosen auto RGB, and it would have been a quicker, more convenient way to do that. Okay, so now I have this color image, but as you can see, one of the fun challenges of working with M42, the Orion Nebula, is that it has a very bright core that can seem a bit overexposed. So again, I have the display stretch module here that we can make use of, and you might say, well, that made it worse, and initially that is true. It can, more often than not, it can make it look worse initially, but that's where you need to adjust the sliders. But I'm also going to make use of color calibration as well. So this is its own module. And the reason I want to do that is because I noticed that the stars in this image, for some reason, they do have somewhat of a teal, a bluish tint to them. And so I can make that adjustment here for this top end balance. I can adjust the red component here all the way to the right. And you can see now they look more white, balanced, if you will. And so that could be an adjustment. If you wanted to make that, you could. There's really, that's one of the things here to note, is that there's really no one correct way to do this, but I'm just demonstrating the different tools and options available. So now we want to take care of this overexposed core. So again, here's the display stretch here, and I can move this slider over to the right a little bit and move this one over to the left some. And I just kind of keep doing this until I'm happy with that initial result. And that looks okay again initially. Now this looks like it might be somewhat, if you will, washed out. The background seems a little bit too elevated. And so then I can adjust this slider here and take care of that. So again, lots of different ways to manipulate this data. If you do this too aggressively, this top slider, then it looks really noisy. So just keep that in mind. So again, just something to experiment with until you find the desired result. And if I wanted to, I could also adjust and mix in a little bit more red color. Of course, when I do that, I'll have to adjust the stretch a bit more. But again, this looks pretty decent, again, from a 50mm telescope from my very light polluted backyard. And if I wanted to, I could save the result. So I can go to File, Save Entire Field at 1x Zoom. And I can give it a file name. In fact, I already saved it once before, but I could give it another one here. So this will generate a ping image. And then I could proceed to carry on editing that if I wanted to. But again, for now, this shows what kind of capability you have built into this software. So with that, let's go ahead and take a look at the next example. Okay, so here is the second example. I've got data from a monochrome camera, and as you can see, the filter column here indicates we have red, green, and blue, as well as a luminance channel that can be populated as well. So again, I always like to go to action view images just to see what I'm dealing with, and this will take a moment because this is almost 10 gigabytes of data across 100 images. So here we have, again, this first image. This is a luminance image with a 60-second exposure, and this is the Helix Nebula. So if I want to, I'm probably, is my second step here after I've looked at it. Again, this is a monochrome camera, so I do not need to do debayer. Again, keep in mind, if you have not already calibrated, you would do that first. But again, you only do the debayer operation if you're working with data from a one-shot color camera. So in this example, I am not. This is data from monochrome, so I skip that step. And I'm just going to go ahead and do plate solve images. But to keep this example quick, I've actually done that. As you can see, all of the images have already been plate solved. So this allows me to do alignment. And if I want to, I could do WCS match. Or once again, I could just go ahead and choose the drizzle mode of operation here. So I might as well do that just as I did in the previous example. So I click OK. And I'll go ahead and give it a moment here. Again, it's going to be working through almost 10 gigabytes of data. So it's a lot of data to process, but we'll go ahead and give it a moment here to see what that looks like. So I had to generate a coordinate buffer, again using the plate solution, and there it's already finished. That took less than 10 seconds to create these different stacks. So I can go to action view images, and here it is. Obviously, as you can see right away, we'll have to make use of that display stretch functionality. But before I do that, I like to go ahead and do selection by filter to do the channel mapping. So in this example, because I do have these different filters like so, if I try to do auto RGB, well, it may work, it may not. In this example, it did work because, again, they do have a common naming to them. But if you happen to have different names, if your red filter, for example, is named something different, maybe it's hydrogen alpha or something, you'll have to do the custom mapping. In other words, you'll have to select the filter and then click apply to whatever color channel that you want. So again, these color channels have now been populated in this table, and you'll notice it looks a bit washed out, and that's because we've given the luminance channel the same kind of coefficient as the other channels here. So if I wanted to, I could dial it back a little bit more, and then I could adjust this contrast setting here. This is using a linear stretch, so I actually don't really need to work with a hyperbolic stretch. This actually looks pretty good already. Now I'll also point out in this image, we do have some streaked, what look like artifacts from the data. So the calibration did not quite get rid of all the hot pixels. So what I would want to do there is to actually perform the drizzle operation once more. This time I'm going to choose a median method. And so median will allow it to basically take care of that kind of noise in a more reasonable fashion. So let's go ahead and take a look at that real quick. Again, that shouldn't take but maybe 10 seconds to go through and process the data. So now that I've done that, again, I can go ahead and do display stretch and also auto RGB and bring down the luminance a little bit. And so here, once again, we now have this image, and because I chose the median operation, it is much more clean data at the end result here. So that's about it for this video. I want to thank you for watching and see you next time.